Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is word search and is a medium level problem. So if by the end you feel that this video was helpful for you, then consider dropping a like on this video and don't forget to share your thoughts on this particular problem down in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach more people like you who want to keep solving new problems. So again, I believe like Geeks for Geeks is trying to repeat old problems for the problem of the day, and this is also an old problem, and it is a very standard problem. You can see by the number of submissions, 21,000 submissions. That means this was not uploaded today. So this is a standard backtracking problem. Although I would say if you have some prior knowledge of like doing DFS in a grid, then it would be much helpful, and the code will be much easier to write, right? So let us discuss what the actual problem says. It says that we have been given 2D board of letters and a word, right? And we have to check whether a certain word exists in a board or not. The word can be constructed from the adjacent letter cells only, right? So if you are in one cell, for the next letter you can move to one of the adjacent cells, either up, down, left or right, right? They also say like they can be horizontal or vertical neighbors. Now the same letter cannot be used more than once. Like this is also very important, because this just changes the dynamics of the question. Like there is just one extra thing that you will have to add to take care of this particular statement, right? So let us see what the test case says. I would say like let us discuss the second test case in which the output is coming out to be false, because it also includes the last condition of our question. So we have a grid like this. So we have A, B, C, E, then we have S, F, C and S, then we have A, D, E and E. Now the word that we want to form is S, A, B, F, S. B, F, S, right? So one way of doing this is like you can start from here, this particular S. So you have encountered one S. Now you can move one of the four directions. So I move upwards. So I now encounter in A. Then I move to the right and encounter a B. And then I move down, then encounter a F, and you see now I'm trapped because the next character that I'm looking for is S, and even if I move in all the four directions, left, right, up and down, I will not be able to find an S. If there is an S that hasn't already been taken, so I cannot take it again, right? So that is why the answer for this particular test case will be 0. Similarly for the other S also, if you start from this S, there will be no A itself, so you cannot continue from this particular S. Now the thing is, if this condition was not present, you could have always gone from this particular F to the original S, and you could have added it here, right? But since you cannot take the characters that you have already taken, that means you cannot do this particular operation, and your this particular operation will end here, and the answer will be 0. Let's say this was not D here, this was S, right? So what you could have done is you could have gone from this particular F to this particular S, because this S was not already taken. So your answer will be this, and as you found the whole string, the answer will be true for this particular test case if S was here, right? So this is how the question works. Now basically what you'll have to do is, you have a grid, right? You have a grid and you have a word. So let's say this is the grid and you have a word, right? So it's more like TFS, because from every point you will have to visit 4 directions, right? This part is very clear, because I want to check whether I can go in that direction or not. So what will be the actual logic of checking whether I can go in that direction or not? So initially my position will be 0. I can only start my DFS when the character in my word at this particular position is equals to the character in my grid at that particular position, X and Y. So it will be denoted by a coordinate. So a cell in the grid will be valid only if the character that I am looking for in the word is equals to the character that is present in that particular cell in the grid. So initially my position value will be 0, because I am looking for the 0th character or the first character in my string. Since I am looking for the S or the 0th character, I'll just traverse through the whole grid, and I'll look for S. As soon as I have found S, I'll start my DFS from there, right? So let's see, we have an S here, so this would be my first cell that I visit, right? Now from this particular S, I'll try to explore all the 4 directions. So if I am at S, I will try to explore all the 4 directions, right? So in this case, I would have gone down, up and right, since I cannot go left because I'll be out of the grid in that particular case. So now I see, how do I verify whether these up, down or right position are valid or not? I'll have to increment my position to position +1 because I've already encountered my first character, right? So once I've encountered my first character, I'll increment my position. Now position value will become 1. So word of 1 will now be equals to A. So the next cell that I'm trying to go at x comma y should have this particular character A. Then only I can go into that cell. So that is why I check whether this is A or this is A and or this is A. Even if one of them is A, I'll go in that particular direction. So my TFS from here will actually go to the upper cell and the down cell, both of them, right? So this is how you will implement it using TFS, and position will get increased each time I'm encountering a new character and I'm going in that particular position. So if this is recursively calling the same function, DFS function, again and again, our base case will be when the value of position becomes word dot size minus 1. Why exactly word dot size minus 1? Because when the value of position is equals to word dot size minus 1, that means you have reached the final character, right? That you have reached the last character of the string that we needed to find. Since we have reached the last character, there is no need to check further and we can just directly return that we have found an answer and I can return true from here. So I can return 1, right? So this is how the problem will work. And also you will have to take care of some other things as well, and that is we don't want any word to be repeated. So for each DFS call, you start from the first character, right? From the first character, this is the first character, you will have a visited array, right? Let's say this is of size n comma m. So now for each cell you visit, you will mark it as visited, and as you move on further from that particular cell, you will check whether the next cell is visited or not. If it is already visited, then obviously we cannot go there. Otherwise, we can try to go there only if this particular condition is satisfied. Now again, when you come back from one cell, so for example, this is your first cell, you went here, then you went in this particular cell, then you went, let's say, on the right side, and then you try to go on further. But you observe that there is no valid path from this particular cell, right? You're not able to form the final word. So what you do is you backtrack to this particular cell, and while backtracking, you will also have to mark this particular cell as not visited, right? So initially, when visiting this cell, you marked it as visited, but when you go back, you will also have to mark it not visited. Why? Because it might also happen at the next cell you visit, right? From there on, you have a path going on like this, right? Which might have been a valid path, but because you marked it visited, you cannot visit this cell again. So you will have to make sure that you mark it as unvisited again, so that if there is any other path including this particular cell, you can visit it, right? So these are the some implementation details that you need to take care of, and I don't think that there is any other thing that we have to discuss in this particular problem. Now let us have a look at the code directly. So you see that I have created two variables n and m, which will denote the dimensions of the board that has been given to us in the input, right? So these are the dimensions of the board, and I have created a visited vector of size n cross m. Now I have created two vectors dx and dy. So this will be used for the DFS and traversing all the 4 directions. You will see in a while how these are used. I have a valid function. I'll tell you what this does. We have a DFS function, but most importantly, let us look at this last part first. So what I'm doing is I'm trying to traverse all the cells of the grid, and only if this is valid and if my DFS returns true, I return 1, right? So you see the way logical AND works in C++ or in any general language is that whenever the first condition is true, only then the second part is executed. If the first condition is itself false, the second part will not be executed. So it will check whether the whether this is valid or not. The current cell ij with position 0. You see, I am also passing the position. So this particular position is the position of the character that I am looking at in the grid, right? So only if this position is valid, this DFS function will be called, and only if this position was initially valid and DFS function was called and it returned true, right? Only then this whole statement will return true, right? Although this is not necessary to write it in one line, it's just a neat way of writing code. Otherwise, what you could have done is you have just have checked whether it is valid, and in the next line you could have like have an nested if and again check whether that particular position runs a true DFS or not, and then return 1. But it's just a need to write it in one line. Now let's see what the DFS function does, and before that let us have a look at the valid function. So valid function is basically taking two indexes x and y and our position p. So if this particular condition is checking whether the like any of those indexes x and y are out of bounds with the grid or not. If they are out of bounds, then I will return 0. Otherwise, I check whether that particular position has been already visited or not. If it has been visited, then again I return 0. Right. Now at the end, I can just return whether the board position character at the position x and y is equal to the character I am looking for or not. If they both are equal, this will return true. Otherwise, it will return false. Right. Now, let us have a look at the DFS function. So this is my base condition when I check whether the position p is equal to what dot size minus 1 or not. If they are equal, I can just directly return 1. Otherwise, I set my current cell as visited. I initialize my OK variable with false. Right. So OK false means that this will store whether whether a valid part exists starting from here or not. Right. Now I just checked on the 4 directions. I am trying to form new variables new x and new y. So this will denote the new position. And I am doing x plus dx of I and y plus dy of I. So basically at like this particular position, at the 0th position, x will decrement by 1 and y will remain as it is. So it is as good as moving upwards in the grid. In this particular position, when the value of I is 1, x will get incremented by 1 and y will remain 0. Right, there will be no change in y. So it is as good as traversing down in the grid. Similarly, this will be for the left and this will be for the right. Right. So in this way, like you can write very neat code with the help of these dx and dy arrays. Otherwise, you will have to write if else conditions for all the 4 directions. Right. So once I have got my new position of x and new position of y, I check whether it is valid or not. Once I have confirmed that this position is valid, I set my OK as OK or DFS of this new position, and I'm just passing p plus 1. You observe that I'm also passing p plus 1 in this particular valid array, in this particular valid function, because p plus 1 is the next position that I have to look for. So I pass p plus 1 in my DFS also, and my new indexes new x and new y. So you see I'm using OK or this DFS call, right? So again, similar to this particular and logical AND, in what happens in logical OR is if your OK is already true, so it will never call this DFS function, right? So if your OK becomes true, it is also known as a short circuit condition. If your first element is true in an OR statement, the second part will never get executed. So that is why I have written it this way, right? So this will really help. If you write it like this, let me just write it in the comments. If you write it like this, OK or DFS of new x, new y, p plus 1 or OK, right? If you write it this way, this is like also going to work, but this DFS function is always going to call itself, right? But in this case, once you have found an answer from one of the DFS, other DFS calls will never be made, right? So this just makes your code more efficient. Now, at the end, once I have got out of this for loop, I can just mark my current cell as not visited, and I just return the value of OK. OK means whether I have found a valid path in one of the DFS calls or not, right? So this would be the solution of today's problem of the day. Now let me just quickly submit it and show you to you that this works, and this is a valid code for today's problem. So you see that it passes all the test cases, and yeah, that's it for today's video. I hope that you guys were able to understand the solution. So you guys did, then consider dropping a like on this video, and don't forget to subscribe to this channel. I see a lot of people who watch these videos have not subscribed yet. So if you're one of them, then consider subscribing. Also share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.